So I just want to be able to clarify a few issues on complex numbers and complex conjugates. So, for example, we know that the square root of -1, we give this symbol I, the imaginary number. And so, consequently, I squared is equal to -1. Now, if I take higher factors of I here, if I have I cubed, I can also write that as I squared multiplied by I, which is equal to -1 multiplied by I, or minus I. And I can keep on going. I to the 4 would be the same as I squared multiplied by I squared, which is -1 multiplied by -1, which would be 1. So, for example, if I was to take I to the 17, for example, I could also write this as I to the 4 multiplied by 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 I to the 1. I add all these terms up. 4 plus 4 plus 4 plus 4 is 16 plus 1 is 17. That gives me I to the 17. And I know that these terms here are all just 1 times 1 times 1 times 1 times I. And so I to the 17 can be simplified just as I. So the next thing we can do with complex numbers is perhaps have a fraction which has a complex number on both the top and the bottom, the numerator and the denominator. So I'm going to just give this example of 2 plus 3i over 1 minus 4i. And what I need to do is I need to multiply both the top and the bottom of this fraction by the complex conjugate. And the complex conjugate I'm after is the bottom half. So it's the denominator I have here. And I'm going to take basically the same numbers, 1 minus 4i, except where I have a minus sign, I'm going to change it to a plus. If I had a plus, I would change it to a minus. And we'll see why that works in just a few steps. So I'm going to multiply top and bottom by the same complex conjugate. If I multiply top and bottom by the same thing, I'm effectively multiplying by 1, and it just makes it perfectly allowed. There's no problem with that. So to evaluate this, I just need to multiply out these brackets. So I'm going to have 2 multiplied by 1, and then 3 multiplied by 4i. So that is going to be 12i squared. So that's minus 12. And then I'm going to have plus 3i plus 8i. So that's my top of this. And then my bottom, I'm going to have 1 multiplied by 1. And then I'm going to have minus 4i multiplied by 4i, which is going to give me minus 16i squared, which is going to become plus 16. And then I'm going to have minus 4i and plus 4i. And we can see that by taking the complex conjugate as this bottom half multiplied by itself but with the sign changed, I end up with 1 minus 4i and 1 plus 4i, and they just cancel. So I'm left only with a real component on the bottom. Just evaluating this slightly further, this leaves me with 2 minus 12 plus 11i over 17. So that is equal to minus 10 plus 11i over 17. If I take this for a different example, and I say have 1 plus 5i over 1 plus 7i, and I'm asked to evaluate this, this time I need my complex conjugate to be 1 minus 7i. So I'm going to multiply the top and my bottom of my complex number with 1 minus 7i. So 1 minus 7i on the top, 1 minus 7i on the bottom. So here it was a plus sign, so now in my complex conjugate it's a minus sign. Everything else is the same. So if I was going to evaluate this, I have 1 times 1 plus 5i times minus 7i. So that is going to be minus 35i squared, which becomes plus 35. And then I have plus 5i minus 7i divided by 1 times 1, and then 7i times minus 7i, which is minus 49i squared, or plus 49. And then I have plus 7i minus 7i. And if I just get rid of my plus 7i minus 7i, they all 1 plus the same thing minus it is just equal to 0. And so this is going to simplify to be 1 plus 35 is 36. 5 minus 7 is minus 2i, so 36 minus 2i over 50. And that will simplify down. I can divide everything here by 2. That's going to be 18 minus I over 25. I hope this little video helps you with some of your questions and difficulties with complex numbers. If you have any other problems, please let me know.